Good morning to all. Myself Dr. K. Manogaran, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about FIR band stop filter with then characteristics. As we previously discussed this, how to find this response curve and integrating it and finding this h of z. The filter transfer function we have already completed. Now we are going to do the remaining things. So first thing we need to make it is a realizable filter. So the transfer function of realizable filter, so very simple, we need to multiply with z power n minus 1 by 2. So h of bar of z equal to z power n minus 1 by 2, 11 minus 1 by 2 will be 5. So z power minus 5 into h of z. So we have already found this h of z. So just we need to multiply with z power minus 5. So we need to multiply z power minus 5 with all these coefficients. So if you multiply this, we get a z power minus 5. Here multiply with this, so plus 2 minus 2. So z power we have minus 5. So minus 5 becomes minus 3 and minus 7. So we have 4 here. So into z power minus 5. So it becomes z power 1, that is z power minus 1 into z power minus 9. Look at this coefficient. So minus 0.137 into z power minus 1 and then 0.2757 into z power minus 3, 0.667 into z power minus 5, 0.2575 into z power minus 7 and then minus 0.1378 into z power minus 9. Look at this. So from this I can write the filter coefficients. So h of 0, 10, 2, 8, 4, 6, there is a no value in this expression. So we can put it as a 0. So we have 1, 3, 5, 7, 9 only we have the value. So 1 equal to 9 equal to minus 0.1378. Look at this value and this value. Similarly, 3 and then 7. Look at this. 3 and 7 we have same value. So h of 3 equal to h of 7 equal to, that is 0.2757. h of 5 we have only one value. This is 0.667. I am writing here. Now from this I need to find an a of n and a of 0 to write this expression. So h bar of e power j omega equal to summation of n equal to 0 to n minus 1 by 2 a of n into cos omega n. So first we need to find a of 0 and a of 1. So a of 0 equal to very simple formula h of n minus 1 by 2. So n minus 1 by 2 is 5. So this is h of 5. So h of 5 value is 0.667. This is a of 0. Now we need to find a of 1, 2, 3, 4, 5. So a of n equal to 2 into h of n minus 1 by 2 minus n. So if you substitute it, 11 minus 1 by 2 is 5. So a of n becomes 2 into h of n minus, that is 5 minus n. So we substitute it, a of 1 equal to 2 into h of 5 minus 1. Instead of n I am putting 1 here. So this is 2 into h of 4, this is 0. A of 2 is 2 into h of n minus 2, this is 5 minus 2. So it becomes h of 3. A of 3, so 2 into h of 5 minus 3, this is h of 2. And then a of 4, 2 into h of 5 minus 4. And then a of 5, 2 into h of 5 minus 5. This is h of 0. So I am substituting this, I am finding this value. I am rewriting this h bar of e power j omega by substituting this a of 0, 1, 2, 3, 4, 5 values. Once if you substitute it, after that we need to take this expression and we need to substitute from 0 to 180 degree. Look at this. I am incrementing with 15 degree, 0 degree, 15, 13, 45, 60 and then 75. So I am incrementing these values. I need to find two things. One is h bar of e power j omega and then I need to make it is in terms of dB here. Look at this actual expressions. So we have this a of 0 value and then we have a of 2 value and then we have a of 4 value. So actual expression we get is h bar of e power j omega equal to, so first value a of 0, this is 0.667 and then we have this value of a of 2 no. So 0.5514 into cos 2 omega and then minus 0.2756 into cos 4 omega. So this is the only we have this is we have substituted n. Now we need to substitute this omega value. So omega value should be incremented from a 0 to 180 degree. Each one we need to substitute from this expression. Once if you substitute it, we get the h bar of e power j omega. So each expression omega, we need to replace this 0 degree, 15 degree, 30 degree, 45 degree up to 180 degree. I need to simplify this expression that we get a h bar of e power j omega. Once if we find that this, sometimes we may have a negative value, sometimes we have a positive value also. And then if you take a logarithm with a negative value, it becomes infinitive. So we need to take a modulus for this value. That means whatever the values minus or plus, we need to make it as a plus. So here all the cases we get a positive value only. Some cases we get a minus also. So we need to take a modulus, so it becomes a positive, and then we need to take a logarithm for this expression. So this is have a 0.9428, no? So take a logarithm for this. So log of 0.9428. After that we need to multiply with 20. So that value only, this is minus 0.5. Similarly, each value we need to substitute. So we take a logarithm and then multiply with 20. So here we have the values, take a modulus, take a logarithm and multiply with 20, we write here. So for a plotting response, we need to take only this omega and then h bar of e power j omega in terms of dB. So this first value and third value we need to take it and plot it. Look at this graph. So from 0 to 0.5, around approximately cutoff frequency, it is decreasing. After that we have small oscillations. After that it again incrementing. So this is a band stop filter. So look at this, from this range, from this cutoff frequency up to this cutoff frequency, the values is stopped or blocked. So we have small oscillations, it become always we have some oscillations, but actually we have passing that lower than this first cutoff frequency, and then we are passing this greater than second cutoff frequencies. Thank you.